Yeah, good morning. Yes. Today we'll see about migrating into a cloud. We know what is meant by cloud, what is meant by distributed computing, what is meant by distributed system, what is parallel computing, what is data parallelism. All these things we have seen, and now we'll see what are the things to be considered while migrating into a cloud. That means we'll be having an enterprise application with us. Okay, without this cloud, we are having an enterprise application that we wanted to migrate to a cloud. That means we wanted to make use of cloud in order to execute the same application. Okay, what is the advantage of migrating into a cloud and all? That will it will be seeing anyway once again in other perspective. Got it? This is the objective of today's lecture, that is migrating into a cloud. So now, first of all, what is meant by cloud? It's like a distributed environment, paper use, elasticity. These all are several properties characteristics that we have discussed with respect to cloud. So this is a combination of all those characteristics and whatever the definitions we have seen. Uh, some of the points what you call combined together to form this kind of definition for a cloud computing. See here, it is a techno business disruptive model of using distributed large scale data centers. Okay, distributed systems in the sense distributed systems, either private or public or hybrid. In the last class we have seen what is meant by private cloud, what is meant by public cloud, and what is meant by hybrid cloud. Yeah. So either of these three will be using, which is offering customers a scalable virtualizer infrastructure. Scalable in the sense that elasticity, we could able to extend if you wanted to. If you want more resources, we can able to shrink. If you want to shrink. Okay, this is what scalable virtualized infrastructure and an abstracted set of services. These can be like some softwares also we can provide as a services. So such kind of services we can offer by service level agreements. In the this is SLA, service level agreements, in the sense up to what time. Okay, what is the duration to be used, and what is the capacity, what kind of computing resources, what kind of storage resources, what kind of connecting devices you wanted to use. These all things will be part of service level agreements called SLAs. Okay, and charged only by the abstract IT resources consumed. So whatever the resources we consume, for those only we have to pay, that is pay per use. So it is like combination of whatever the things we have discussed so far with respect to cloud computing. Those all are part of this definition. See here, distributed systems covered, cloud types covered, that is private, public, hybrid, and scalability, that feature scalable infrastructure we are providing, and abstract set of services, in the sense of software as a service we have seen in the previous class. So that we are covering, and SLA, and charged only by the abstract IT resources consumed. So up to whatever extent we have consumed, that only we have to pay. So these all are part of the cloud computing. Okay, just it is a recap of whatever the things we have seen. Yeah. Next, here you see these are the some of the preliminary terms that we need to know in order to continue our topic. So that if you are familiar with these abbreviations and all, it will be helpful in further discussion. First of all, TCO in the sense total cost of ownership. That means for utilizing that particular vertical cloud resources, how much we have to pay. It is this can be measured by using a calculator provided in the form of TCO, total cost of ownership. In order to own those resources for a certain amount of time, what is the cost? Okay, so here the formally it is a calculator. TCO is a calculator used to estimate the cost savings you can achieve by migrating your application workloads to new technology. What is that new technology? It is nothing but cloud. Okay, whatever the existing application that we have, if you migrate that to a cloud application, then how much saving you could able to achieve, that will be calculated by using the calculator called TCO. Okay, total cost of ownership. Next, return on investment. That is nothing but ROI, return on investment. It is a ratio between net profit and cost of investment. How much you are investing and what is the profit that you are getting. A ratio between these two we can consider as return on investment. That means if we have more ROI, what does it mean? Net profit is more. That means automatically what we can consider net profit and cost of investment. If you can what you call compare, net profit is more. What does it mean? It is giving what you call advantage of that using cloud, isn't it? That is nothing but ROI. Next, in order to establish the cloud, we need to invest something. Okay, isn't it? We need to invest in the sense infrastructure or some software or some platform we have to hire. I'm repeating once again, infrastructure or software or platform that we have to hire. Okay, in order to hire that particular one, we need to pay some money. That is nothing but capital expenditure. Capital expenditure that we will be denoting as CapEx. This is capital expenditure. Next, after establishing that particular cloud, okay, some operational cost might be there. Operational expenses that we denote with OPEX. Capital expenditure, operational expenditure. This we can consider as operating expense, operating expenditure, operational expense or operational expenditure or OPEX in short. Okay, it is nothing but it is ongoing cost for running a product. Okay, while using that particular one, we may require some service. It's like some repair work we have to do or some sort of maintenance we have to perform. So the cost incurred for these kind of activities we can consider as operational expenditure, that is OPEX. Capital expenditure is nothing but cost of developing or providing non-consumable product parts for the product or system. What is meant by non-consumable parts? Non-consumable parts. Can we say anything? Non-consumable parts. Consumable parts. Consumable what you call things means. Yeah, please respond. Yes. See, in our at our home we will be having lot of things. Consumable things will be there, non-consumable things will be there. Now you can figure out what is meant by this. Yeah, consumable thing, non-consumable thing, both will provide some sort of facility, but how we can differentiate whether this particular thing is consumable thing or this is non-consumable thing, like that how we can let us see let us say like you are having a gas stove at your home. Okay, gas stove at your home, is it consumable or non-consumable? Gas stove and gas cylinder. Gas cylinder, there we are consuming the gas. Okay, so that is consumable thing. Non-consumable thing is gas stove. Okay, that will we will be utilizing, but it will stay like that only, right? So that is non-consumable part. Like that, whenever you come to this cloud things, suppose in order to put all the processing units and all, we will be using some stands and all. Okay, those are non-consumable parts. Okay, how much ever you will be using, those will stay like that only. Understand what I'm saying? Yes, please respond now. Anyone? Yes. Yeah, Ganesh, are you there? Ganesh. Okay. Next, this is about operational cost and capital expenditure. Next, coming to CDN and DNS. CDN is nothing but content delivery network. What is DNS? Domain name system, or no, domain name server. We can say it's like we'll be having IP address for our system. Whenever we try to communicate with other system through IP address only, we have to communicate. It's like suppose a Google server, you if you wanted to communicate, or some Facebook server you wanted to communicate, means that Facebook server IP address you should get. Similarly, Google server IP address, like that, for every system you need to know the IP address, then only you can communicate with it. But remembering those all IP addresses for like suppose a 10, with the 10 systems you wanted to communicate, means 10 IP addresses, 10 IP addresses we have to remember, isn't it? This is very tedious task for the user. Okay, that's why there is a convention called DNS. What it will do is, whenever you type google.com, then it will go to DNS server. DNS server, then their searching will be happened. Google.com means what is the corresponding IP address. This is the IP address. Then that will be given to your system internally. To that particular IP address, communication will be initiated. Understand what I am saying? This is DNS is nothing but it will act as the intermediate device between our system and the required system which we wanted to communicate. What it will do is, whenever we try to communicate by using some website address, then that website address will be searched in that server. Then corresponding IP address will be fetched. That IP address will be used to make the connection with the required server or required system. Okay, this is what the what you call operation of DNS, domain name system or domain name server. Got it? Now, content delivery network, CDN. It is nothing but whatever the DNS requests we will make, okay, in order to deliver those DNS responses in very less time, we will be maintaining some servers in order to fulfill the need. It is like CDN, content delivery network, is a highly distributed platform of servers that helps minimize delays. Okay, minimize delays in loading web page content by reducing physical distance between the server and the user when the browser makes a DNS request for a domain name. So domain name is nothing but google.com, facebook.com, or gmail.com. These all we will be using, right? That is called domain name. Whenever user enters domain name, that will be given to DNS server, okay, in the form of DNS request. Then DNS server will respond as the by giving the IP address. Okay, so in order to reduce the distance between physical server and the user, okay, in order to while requesting DNS, okay, while requesting actual IP address, we will be using this CDN, content delivery network. What it will do is, it will minimize the distance. How it will minimize? It's like just it will maintain at several places the same data. That is what it will do. It's like You say there is one DNS exists for all the people in the world, then all people has to send the data in the, like google.com, that request to that particular server only. Then automatically the delays will be more. Instead of that, what they will, how they will maintain is same data they will keep at several servers. Okay, at several servers, a lot of servers they will be maintaining with the same data. Whenever request is given by the user, that request will be sent to the nearest server, nearest DNS server, so that that searching can be done here itself, which is nearer to the user. After that, that IP address will be given, then user can communicate with the intended uh, domain or intended server directly by using that IP address. This is what the operation of DNS. Got it? I think you should get this thing in computer networks itself. Do you have idea about it or not? Yes. Okay. Actually, this is very interesting thing. Okay. Let me spend 1-2 minutes on it. See. Yeah. See. My suppose if you type some IP some website address like facebook.com, if you type in your browser, you will get some page, right? What does it mean? We are communicating to the Facebook server page. Okay, Facebook server, we are communicating to the Facebook server, then that server is giving this page. This is what happening. Okay, that is visible to us. In general, we can understand. But in order to achieve this kind of functionality, there is some process that whenever we type facebook.com, it will not go directly to the Facebook server. It will go to one DNS, one another server, which is called DNS, domain name system. What we are giving to this particular domain name server is facebook.com. That input we are giving to this particular DNS. Then here we will be having a table kind of thing, a table where one column we will be having as domain names, facebook.com, google.com, gmail.com, like this entire list will be maintained, and corresponding IP addresses also we will be having. IP addresses, you know, right? IPv4, IPv6, these formats will be there. Some IP addresses 192.168.0.1, something like that. We'll be having 4 octets. 4 octets. Each will be of 8 bits, 8 bits, like that. We'll be having in IPv4. IPv4 is the 4 octets. Okay, 32 bits, 8 into 4. 32 bits, 32-bit address we will be using in order to identify any host in the internet. Okay, so when in this particular DNS, we'll be having a list which consists of two columns. One is domain names, another one is IP addresses. Okay, corresponding IP address will be fetched, okay, from this table, and that will be given to our system. Then our system will make a request to the intended server directly. Then we could able to communicate with the Facebook server. Got it? This is what in general the scenario when we try to access any web page in the internet, we should provide IP address corresponding to it. Okay, but as remembering IP addresses for each and every website, it is a tedious task. Okay, it will degrade the article usage of internet because of this particular problem. That's why they introduced a concept called domain name system, where we will be maintaining, or that server will maintain all the IP addresses corresponding to the domain names. That is, it's like in other way you can understand. Instead of remembering IP addresses directly, we have to remember only domain names. Okay, for these IP addresses, domain names given. So these domain names we will be using while entering in the browser. This is what DNS. Got it? Yes.
Yes, sir.
Okay. Next, CI or CD. Here, this refers to the combined practices of continuous integration and continuous delivery or continuous deployment. CI or CD, continuous integration, continuous delivery or deployment. Okay, this is what this bridges the gaps between development and operation activities and teams by enforcing automation in building, testing, and deployment of applications. It's like suppose some up to some extent you have developed a website kind of thing, then you can deploy it. Then after some time, if you enhance some more features, if you add some more features, that will be added. These all things are common practices that we can refer as CACD, continuous integration, continuous delivery. Okay, these are some of the preliminary terms that we need to know in order to discuss further things. Yeah, cloudonomics here, the promise of the cloud in the sense like cloudonomics. Here they will be dealing with operational costs, capital expenditure. What is the amount that the user has to pay in order to utilize cloud? These all things will come under cloudonomics. It's like economics, right? It's cloudonomics in the sense how much we have to pay, what is the what you call what is the profit that we'll be getting out of this profit. How we have denoted this TCO, right? Total cost of ownership. So such kind of things will be referred under this cloudonomics. So here you see paper use, lower cost barriers. Paper use, very low cost we should provide. Next, on-demand resources, auto scaling. Well, suppose if you deploy your application in the cloud, if you wanted to have database of other kind, then it should able to provide such kind of on-demand resources. Suppose if you wanted to communicate, if you wanted to connect with 200 users instead of 100 users, you have set up for 100 users, but you wanted to connect now to you wanted to scale it up to 200 users, then it should allow such kind of things. Next, what is the operational costs? There should not be any capital investments. Okay, no capital expenses here. Why? Because we no need to establish all the things. Whatever the infrastructure already exists, that only will be using. Only operational expenses we have to be. Okay, next, SLA driven operations. It's like much lower TCO, total cost of operation. What is it? TCO, total cost of ownership. Sorry, that TCO should be less. These all are related to cloudonomics. Next, coming to technology, here elastic availability, infinite elastic availability. This that means computing power or storage or bandwidth, anything. We should give an illusion to the user that we are having infinite storage, infinite bandwidth, we have infinite computing power, we have such kind of illusion we will be providing through this technology. Okay, automatic usage monitoring and metering. Okay, how much we have used, that has to be measured. The jobs virtualized and transparently movable. Integration and interoperability support for hybrid operations. Transparently encapsulated and abstracted IT features. These all are some of the promises which will be provided out of these cloud computing technology. Cloudonomics technology, of course, both are interrelated. Actually, these are not independent to each other. Both are what you call having inter dependency. Like how cost will be measured, vertical, depending upon the resources that we have utilized, the cost has to be measured. All these things are interrelated: cloudonomics and technology. Next, the services, depending upon the service that we get, there are three types of services, right? Infrastructure as a service, platform as a service, software as a service. Who will be providing which service and all that we have seen. Okay, these are some of the examples of infrastructure as a service. Amazon Web Server, EC2, S3, SDB, these all are infrastructure as a service. Coming to platform as a service, Google Apps. Next, software as a service, we are having Salesforce.com, Gmail, Yahoo Mail. These all are software as a service. And we have deployment models as three models: public cloud, private cloud, hybrid cloud. Okay, these are the three types of deployment models. These all we have seen, that's why I'm going directly. And now the question is, why to migrate? Of course, this is more or less these all points, just what is the advantage of migration? That is the question here. Why to migrate? In the sense, scalability to accommodate growing data requirements. Suppose if you develop a web application or mobile application, which let us consider this railway inquiry. You consider railway inquiry. There you will be providing an interface to check from source to destination what are the trains and what are the train timings and all. Okay, for this you have used some database, and from that database you will be fetching, and some user interface you have created for it. Now the thing is, you wanted to incorporate even bus information as well in the same thing. From source to destination, what are the available transport systems we have, all those you wanted to list. Then your data has to be more, right? Definitely train data you have to maintain, and bus data also you have to maintain. Okay, it should be able to accommodate such kind of growing data requirements. How we can able to provide such kind of environment is, if we use cloud, then we will be having infinite storage in general. Virtually we will be having such kind of thing, so we can able to scale it. Okay, like that. Why to migrate? These all are advantages actually. See, business continuity and disaster recovery, and the name itself indicating. Yeah, for example, how many of you know IRCTC? Anybody knows IRCTC? Yes or no? Yes, please respond now. Yeah. Here, oh, just a second. Yeah, I missed the point. What I wanted to do. Yeah, this IRCTC will require some things to be updated. It's like some new trends have to be added, or some timings have to be changed, or fare has to be revised. All these things it has to do. Suppose if you try to do it in directly, what will happen is, while seeing from source to destination, if it shows suppose let us consider 1,000 rupees is the cost. Okay, while paying, it will show like if you update the price without any notice, then what will happen is, while paying it will show suppose 1,200. Then customer will lose his reliability on the system, his trust on the system. Understand? That's why what IRCTC will do explicitly is, every day 20 minutes to 30 minutes in the midnight, like 11:40 to 12 or 11:40 to 12:10, they will not allow any customers to book. Do you have idea about it? 11:40 to 12 or 11:40 to 12:10, they will not allow any customers to book any ticket. Why? Because they will be performing some maintenance things in that particular time every day, not only on price changing days. Every day they will do some sort of what you call maintenance things, okay, in order to continue the business without any interruption. Got it? Such kind of thing. Even physically or unofficially, we can say whatever the servers they will be maintaining, they will restart that server so that the maintenance will be easier for them. Such kind of activities they will perform. Okay. Further, do you have an idea? If you have idea, then automatically you will sync to this. Yeah, this is business continuity and disaster recovery. Faster development iterations and reduced provisioning time, improved IT resource management, improved cost management, collective IT insights, data security, reduced carbon footprint. What is meant by carbon footprint? One? Carbon footprint. We discussed this point earlier. It is like we can if you see from last 5 6 years, we can say how many mobile phones are thrown or kept aside at your home. At least 2 3, right? At least 2 3 phones kept aside without any usage. Those all are carbon wastage, right? Like that, if every enterprise, every organization establishes their own setup to provide services, then what will happen? There will be more carbon wastage, isn't it? After some time, some years, there will be more carbon wastage. Instead of that, same services will be utilized from the cloud, so that that carbon wastage will be reduced. By because the same infrastructure will be utilized by so many people, isn't it? Like we had discussed at some point, like morning to evening we'll be having office, remaining time those systems will be idle. That time we can give it to some other users who will need it. Okay, in that particular case, instead of using two systems, we can use only one system. Morning one person, evening one person. Like that, we can reduce the carbon wastage, carbon footprint, in the sense whatever the um, what you call what you call electronic devices that we produce. Okay, that we uh, produce in order to fulfill our needs, we can say it as carbon footprint. That carbon footprint will be reduced when we migrate to cloud. These are the reasons for migrating into a cloud. Next, coming to the key considerations, what is the type of cloud that we are using, where we are using, and what are the implications of these kind of what you call migration, what is the security barrier, when we lost the data, what is the recovery mechanism and all. Okay, can we able to switch to some other service, we can switch to some other platform if you want. These all things are the considerations while migrating into a cloud. See, these all points will come whenever we wanted to migrate to a cloud. What type of cloud we want, where we want, and what is the security implications, what is the recovery implications, what is the it's like when we try to migrate, what are the considerations. That is nothing but portability. These are all things we have to consider while migrating. Okay, next, of course, these all we have covered. What to migrate, how to migrate, where to migrate. See, what to migrate in the sense, prioritize the applications, processes, and infrastructure to be migrated. Okay, first, these are the things that we have to migrate. Like that, we have to identify. Next, how to migrate in the sense, we have to frame a migration strategy. Okay, migration strategy that we will see. Then, where to migrate in the sense, whether it is private cloud or public cloud or hybrid cloud, that we have to see. This is about where to migrate. Now we will see the process of how to migrate. See, this is a 7-step model for migrating into the cloud. 7 steps we will be performing in general. Conduct cloud migration assessments. Some assessments we have to conduct. That means some sort of discussions or estimates, all these things. Next, this is actually there won't be any physical thing that will happen in the first step, that you remember. First step, we will not do any physical things. Second step, we will isolate the dependencies. Like some components will be there. Those all components we will make it as independent. That means every component we can deploy independently. That's what we will do in second step. Next, map the messaging and environment. So whatever the independent things, independent components we have made, okay, what are the resources that we require in order to make those components deployed? Those kind of mapping we will do in the third step. Next, now accordingly we will redesign or re-architect the entire functionalities to implement what are the last functionalities we will be having. It's like we are isolating the dependencies, right? And that is independent modules we are making. While doing so, what will happen is some of the functionalities we cannot make independent. Those kind of thing, for those kind of functionalities, we will re-architect or redesign again in order to get those lost functionalities. Okay, fifth step is leverage cloud functionalities and features. Then sixth one is test the migration. After leveraging, we have to perform test whether it is giving all the features which we intended or not. That a test suite we will be using. Accordingly, we will perform testing. Then, if it is not matching the required thing, then we have to perform same activities again. That is again assessment we will be performing, isolate the dependencies, map, re-architect, leverage, test. Again we will, after testing, we will check whether it is acceptable or not. Otherwise, again we will perform same steps. This we will be performing until we reach our required model. This is what a 7-step model for migration into a cloud. Okay, and then same thing here you can understand. The 7th step is iterate and optimize. In the sense, whatever the six steps we have, those all 6 steps we will be performing repeatedly until we get the required model. This is what we will be performing. See in this. First we will perform assessment. Some assessments will be performing, then isolate the dependencies, then map, then re-architect. Argument, of course, these two are part. Next, test. If it is meeting, then it's fine. Otherwise, we have to go to again same cycle. So this is one iteration. This is like this. For every iteration, we will be performing all these steps. This is a 7-step model of migration into the cloud. Okay. Next, these are the what you call some sort of aspects that we will be performing in each and every step. In assessment, what we will be what we have to consider. Cloud dynamics will come into picture. Migration costs, recurring costs, all these things will come into picture. That means in discussion, what are the things to be considered are mentioned here. Similarly, isolate the dependencies. In the sense, runtime environment, licensing, libraries, dependencies, application dependencies, latencies, bottlenecks, all these things will come under this particular second step. Now, these things we have to consider. That is what here mentioned. Like that, map, re-architect, augment, test, optimize. All these 7 steps, we will be considering these things while discussing and while migrating into the cloud. Okay, this is what we'll be having in iterative 7-step model of migration. Okay, next, what are the challenges? Of course, right side one you see challenges in cloud technologies. Here some security, performance monitoring we have to perform. Security, we have to ensure consistent meta scheduling, energy efficient load balancing. Suppose some 2 3 servers are there. On those 3 servers, we have to perform, we have to distribute the load in such a way that no system should be idle, and no system should be over utilized. These kind of things we have to um, ensure, that we call it as load balancing, scale management, and QS architecture. These all will come under cloud technologies, challenges in cloud technologies. Okay, this is about migration into a cloud. Got it? So we have seen about what are the um, reasons for migration, and what are the things to be considered while migrating. Then 7-step model: assessment, isolation, map, re-architect, augment, test, optimize. And these things we will be iterating until we get the optimized version of it. Okay, that is intended version of the. This is what. Yes, you can enter your roll number in the chat box and can leave. Thank you.